Example 7, displacement versus distance. A particle moves along a line so that its velocity at time t is v of t, which is equal to t squared minus t minus 6, measured in meters per second. In part A, we want to find the displacement of the particle during the time period where t is in between 1 and 4 inclusive. Okay, so what we're looking for is the displacement where it's s of t 2 minus s of t1. Okay, so we know that the second time is actually 4. So this is s of 4 minus s of 1. Okay, and so what does this equal? Well, this equals the fact that we have a function v of t dt, which has a lower limit of 1 and an upper limit of 4. Okay, now what is the function v of t? Well, we know that the function that's given is t squared minus t minus 6, and that's dt. And so now what we want to do is we want to be able to find the antiderivatives of each term. So if we find the antiderivatives of each term, we know that this is going to be 1/3 t cubed minus 1/2 of t squared minus 6t, and we can evaluate this limit going from 1 to 4. Sorry, the integral. Okay, so now what we're going to do is we're going to plug in the value of 4. So we have t cubed, which is going to be 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. And then minus now the lower limit, which is going to be 1 cubed over 3 minus 1 cubed over 2 minus 6 times 1. Okay, so we're going to go ahead and multiply this out. So we end up getting 64 over 3 minus 16 over 2 minus 24 minus 1/3 minus 1/2 minus 6. Okay, so we can find a common denominator between all of those, and the common denominator is going to be 6. So here we're going to have 128 over 6 minus 48 over 6 minus 144 over 6. And then we're going to distribute the sign. And so we're going to get minus 2 over 6 plus 3 over 6 plus 36 over 6. And so that will reduce to negative 9 over 2, which is equal to negative 4.5. And so therefore, we can then say that this means that the particle's position at time t is equal to 4 is 4.5 meters to the left of its position at the start of the time period. Let's take a look at part B. In part B, it's asking us to find the distance traveled during this time period. Okay, so the first thing we need to do is we need to look at this function. So if we look at this function, we know that v of t is equal to t squared minus t minus 6. Okay, which means that if we factor this, we would get t minus 3 times t plus 2, which means there's going to be 2 t-intercepts. So the 2 t-intercepts are located at t is equal to 3, and the other one is t is equal to -2. Okay, but we kind of want to see what's happening here with this graph before we proceed any further. Okay, so let's pull it up on Desmos. Okay, so we're going to put in the value of x instead of t, so we have x squared minus x, and that's minus 6. Okay, and then we also know there's a restriction here that we have at the beginning of the problem, which means that we're going between 1 and 4. Okay, so we can see what's happening here. So this is our graph. So let's go ahead and I'm going to go ahead and copy this. Okay, so let's take a look at this graph here. Okay, so what do we have? Well, if you take a look here, we can label our points. So we know that this represents 1, this represents 2, this represents 3, and this represents 4. Okay, now the only one that we're dealing with here is where t is equal to 3, so therefore there is where t is equal to 3. Okay, so we're going to have two areas here that we're dealing with. Okay, so one area, okay, is going to be below the x-axis. So we have this area here, okay, which represents our negative area. Okay, and then we also have this area, okay, which represents it's above the x-axis. So then what does that tell us? Well, that tells us that v of t, okay, is greater than or equal to 0, and v of t is less than or equal to 0 in what intervals? Well, we know that it's less than or equal to 0, meaning below the x-axis, from the interval between 1 and 3. And we know that it's greater than between the interval of 3 and 4. So now we can use this information to then determine our integral here. So let's go ahead and do that. So now we have an integral that's going from 1 to 4 of, because we're finding the distance of the absolute value of v of t dt. Okay, so what does that mean? Well, that tells us that we have an integral and this integral goes from 1 to 3. And that represents a negative v of t dt. And then we have plus and now we have this integral that goes from 3 to 4 of positive v of t dt. Okay, so what does that tell us? Well, what that tells us here is that since we know it's negative, we have this integral going from 1 to 3 of negative times the function, which is t squared minus t minus 6 dt, and then plus we have the integral that goes from 3 to 4 of t squared minus t minus 6 dt. Okay, now let's distribute this minus sign, or the negative sign. So now we have the integral going from 1 to 3 of negative t squared plus t plus 6 dt, and then plus the integral that goes from 3 to 4 of of t squared minus t minus 6 dt. Okay, so now let's go ahead and evaluate according to our integrals and take the antiderivative. So when we take the antiderivative, we get negative t cubed over 3 plus t squared over 2 plus 6t, and that's going from 1 to 3, plus we have t cubed over 3 minus t squared over 2 minus 6t, and that's going from 3 to 4. Okay, so by doing that, let me go ahead and make just a little bit of room here. So I'm going to move this over just a tiny bit. Okay, so what do we have here? Well, we know that our first one is going to be represented by that integral that goes from 1 to 3. So using parentheses, we have negative 3 cubed over 3 plus 3 squared over 2 plus 6 times 3, and then minus negative 1 cubed over 3 plus 1 squared over 2 plus 6 times 1. And then we are adding here, because that's plus. Now we have 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. And that's a minus 3 cubed over 3 minus 3 squared over 2 minus 6 times 3. Okay, so if we go ahead and follow that, then we end up getting the following. We end up getting 61 over 6, which is going to give us approximately 10.17 meters. And so therefore this tells us the total distance that's traveled. And again, we had to take the absolute value of that because that allows us to be able to find out what is the total distance traveled. And so by adding those areas, we got 10.17 meters.